All right, let's talk about nuclear fusion. For decades, it's had this reputation, right? It's the holy grail of clean energy, but it's always felt like it was just over the horizon. Well, something has fundamentally changed. All of a sudden, billions of private dollars are pouring into a field that used to be dominated by these slow, methodical government projects.
You've probably heard the joke. Fusion is the energy source of the future, and it always will be. And look, for a long time, that skepticism was totally earned. But it feels like the punchline to that joke is finally starting to change.
Because what's happening right now is maybe the most exciting moment in the history of fusion. We're talking more private funding flowing into fusion startups every year than the entire US federal government spends on it. It's a total paradigm shift.
So what gives? What is behind this absolute gold rush? Is it just a bunch of hype? Or is the dream of limitless, clean energy finally actually within our grasp? That is exactly what we're going to break down.
Here's the plan. We'll start with the basic science, how you bottle a star. Then we'll look at the slow and steady government way of doing things. After that, we dive into the wild west of private startups, weigh all the hype against the hard reality, and finally, explore what a fusion-powered world might actually look like.
So first things first, how do you actually tame a star? Because to really get why all this money is flowing in, you have to appreciate the massive scientific mountain everyone is trying to climb. It all starts with something called plasma. The easiest way to think about it is with water, right? You've got solid ice, liquid water, and then gas steam. Well, if you keep heating that steam up to millions of degrees, the atoms themselves break apart, and you get plasma, the fourth state of matter. And it's inside this superheated, chaotic soup that fusion can finally happen. Now, creating fusion is actually the easy part. The real challenge, the whole ballgame, is that last point on the list. It's called net energy gain. And it's the one thing nobody on Earth has ever achieved. It means getting more energy out of the fusion reaction than you had to put in to get it started. And this really gets to the heart of the problem. See, the sun has a huge advantage, gravity. Its own massive size naturally crushes atoms together. We can't do that here, so we have to cheat. We use absolutely insane temperatures. We're talking 10 times hotter than the core of the sun, and then we try to contain that wild plasma with some of the most powerful magnets ever built. So for the last 70 years, this monumental task has been tackled by these huge government-funded big science projects. These are the places that literally wrote the textbook on plasma physics. They've been playing the long game, patiently, methodically laying the foundation for everything that's happening today. A great example is the JET facility in the UK. Back in '97, it proved that fusion at scale was possible. Then, in 2021, it completely shattered that record. Now, I know, 5 seconds doesn't sound like a long time, but in the world of fusion, it was this monumental leap forward. It proved our control over the plasma was getting so much better. All of this work is leading to ITER, a colossal project in France that's the scientific community's best shot at net energy gain, but they don't expect that until 2035. And that date, 2035, is really the key to understanding everything that's happening now. In a world facing a climate crisis, 2035 feels a long way off, and that slow timeline has created a massive opening, sparking what some people are calling the SpaceX moment for fusion. It's a stampede of private companies who all think they can get there faster, cheaper, and with some totally different ideas. Okay, so let's look at one of these startups, General Fusion. They're a Canadian company taking a surprisingly mechanical approach to what is a very complex physics problem. Their whole analogy makes it so easy to understand. Just think of a diesel engine. They create this swirling vortex of liquid metal, shoot the plasma into the middle, and then, get this, a ring of huge steam-driven pistons smashes it all together, triggering fusion. So the big idea here is they're trying to solve the problem with brute force engineering, using stuff we already know how to build.
And this isn't just a drawing on a whiteboard. With backing from Jeff Bezos, they are actually building a demonstration plant right near the old guard at JET. And their goal? To prove the whole concept works by 2026.
All right, now let's pivot to a totally different idea from a company called Helion. They looked at the standard model for a power plant. Fusion creates heat, heat boils water, steam turns a turbine, and they basically said, that's old-fashioned. There has to be a better way.
Their method is pretty radical. Instead of using heat, their plan is to capture electricity directly from the magnetic fields as the plasma expands after fusion. The best way to think about it is regenerative braking in an electric car. And the game changer here is that if they can cut out the whole 19th century steam turbine part, they could build power plants that are way smaller, more efficient, and a whole lot cheaper.
And this is where it gets really wild. With backing from Silicon Valley titans like Sam Altman and Peter Thiel, Helion is making one of the boldest claims in the entire industry. They say they'll demonstrate net electricity generation by 2024. That's next year.
And for our last example, if you thought that was different, check this out. It's an approach from a UK-based company called First Light Fusion.
They call it projectile fusion. Basically, they fire a small projectile at something like 15,000 miles per hour into a tiny target that holds the fusion fuel. The impact is so ridiculously intense that it triggers a fusion reaction, releasing enough energy from one shot to power a home for 2 years. Their whole angle is simplicity. This could be the cheapest way to get to fusion power because you avoid all the complex lasers and magnets.
So you have all these new players and these amazing ideas. But what this has created is a huge debate in the energy world. It's basically pitting the fast-moving, risk-taking startup culture against the slow, cautious, methodical world of traditional science. On one hand, you have the startups. They argue that with the climate crisis, we have to have a build as fast as possible mentality, just like SpaceX did with rockets. On the other hand, the established scientific community is way more skeptical. They worry that all these bold promises could backfire, and if they fail, it could hurt the credibility of the entire field. For them, a realistic timeline is still closer to 20 years away.
So, with all that risk, why is this happening? Why are smart investors pouring billions into technologies that might not pay off for decades, if they pay off at all? Well, it's because the prize here isn't just a new power plant. It's a whole new kind of civilization.
Let's start with the money, because it's just staggering. The total addressable market for fusion energy is estimated to be around $1 trillion. And that's not the total value, that's every single year. It is, without any exaggeration, one of the biggest economic opportunities in human history.
But it's about so much more than money. We're talking about energy that is so cheap, so clean, and so abundant that developing nations could raise their standard of living without burning a single ounce of carbon. You could power massive machines to literally suck CO2 out of the air we've already polluted. You could mine asteroids, fuel ships to Mars. You could actually restore Earth's atmosphere. It changes everything.
We still don't know who's going to crack the code first. Will it be the slow, steady work of governments? Or will it be one of these risky bets from the private sector? But what's clear is that for the first time in a very long time, it feels less like a question of if fusion will happen and a lot more like a question of when. The race is definitely on.